Welcome to my now Friday afternoon live weather and climate office hour. Apologies for the delay and thanks for joining me. The culprit this morning was, to my knowledge, not squirrels, but instead, I believe someone crashed their car into an electrical pole and took out power to several thousand folks locally. So that is a surprisingly common occurrence all over the country and is incidentally a not uncommon cause of wildfire ignitions. Because, of course, if a large, heavy object hits a power pole at high speeds and knocks those wires into dry vegetation, that can be a recipe for even bigger problems beyond the crash. Fortunately, I don't think that happened in this case, but just a reminder that our infrastructure is susceptible to very many things. By the way, the reason why I mentioned squirrels, for those of you who have followed this saga via social media, is that recent internet connectivity challenges have been associated with seemingly untraceable issues by the ISP, which in this case was Xfinity, although now, having better direct communication with that company, they sent out a veritable team of folks inside and outside the house, and it turned out they found numerous locations where squirrels, presumably, had chewed not just through the protective coating on wires, but all the way into the wire itself, including breaking down some of the copper strands. Some folks have mentioned that they were skeptical that there was actually copper wire involved. Apparently, the conduit does contain fiber optics to the local node, but it is in fact, even for the very highest tier of internet speeds around here, still copper wire from the node to houses. And not only had our wire been chewed straight through by rodents in multiple locations, but the neighbors had also, including people who no longer had service with that company, and apparently there was water getting into the discontinued wires next door, causing signal interference. Overall, quite a mess. Got a bit of special attention, though, from Xfinity this week. I think that's a little more than they would typically give their average customer. So for better or for worse, I think we now have much better physical infrastructure coming to the house. Right now, looks like the signal quality is pretty good. It has been in the past. Hopefully it holds. My fingers are crossed, but I'm more optimistic this time around that the problem has been resolved more in the longer term, given that there was a lot of physical wiring that was nearly destroyed that had been having water seep into it whenever there would be precipitation. So anyway, hopefully that's resolved. Today's issues are unrelated to that problem. But don't want to spend too long on that, but thought some folks might get a chuckle out of the fact that all this time it appears to have been the squirrels after all. Just a reminder that this channel is partially sponsored by Reask, a science-first tech company. That's an important piece, helping organizations manage their exposure to current and future climate and extreme weather risks through predictive, dynamic, and physics-based modeling. So today's session, I want to talk about a few different things on a few different timescales. One is a fairly dramatic, actually, weather pattern shift that's mainly going to affect the Pacific Northwest this weekend, but will also affect far northern California with, frankly, what could be some fairly dramatic midsummer weather, including widespread thunderstorms. So a big, loud storm across the Pacific Northwest, creeping over the border into parts of northernmost California as well. All of that's mainly well north of the Bay Area, I-80 corridor, for example, but this could be a pretty significant event up in Del Norte, Shasta counties, and maybe a little bit further south than that. So I'll talk about that in a minute or two. Talk a little bit about the current relative lull in wildfire activity. It's certainly not quiet out there on the Western Front, so to speak, but it is less active than it was a few weeks ago, closer to the peak of July's record-breaking heat. And yes, as of now, it officially was the hottest July and therefore the hottest month in all of California's recorded history last month. And what's remarkable, by the way, is that California beat its previous record by a margin of nearly 2 degrees Fahrenheit on a statewide average basis for the entire month. That is an extraordinarily large margin to beat a previous all-time monthly record for a region as large as California. So we didn't just barely squeak by. That genuinely did shatter the record for the warmest month in California history, going back well over a century. And but for the lack of observations before that, probably a lot longer than that period as well. So July of this year was truly extraordinary for the magnitude, duration of the heat. Again, the only places where this wasn't necessarily the case, ironically, include some of the most densely populated parts of the Southern California coastal strip. But nearly everywhere else, this was the hottest month that you've ever experienced, or your parents have ever experienced, or your grandparents or their parents before them had ever experienced across most of the land area of California. Not in LA County, though, or a couple other coastal Southern California counties. So the legacy of that extreme heat in July, August, despite the fact that it has felt a lot cooler, has still been significantly warmer than average. So continuing that much warmer than average streak across most inland areas, although the magnitude of that heat has been a lot more manageable. Certainly not record-breaking so far in the first half of August, although it has been a few degrees warmer than the average temperature for August in recent decades. And that has allowed wildfire activity to calm down to a more manageable level. So rather than seeing numerous ignitions and uniformly extreme fire behavior on most of them, we're still seeing pretty regular ignitions, and we're still seeing significant fire activity, but the pace has slowed, and the degree of that activity, the intensity, rates of initial spread are not as high as they were. Nonetheless, vegetation remains drier than average in most places in California, and will likely remain so nearly everywhere in California for the foreseeable future. In fact, they may get even more anomalously dry as we go later into August and into September, given the expectation of a return of fairly widespread anomalous heat once again by the end of August. But the good news, temperature-wise, for at least the next 7 to 10 days, is conditions look like they will be around average temperature-wise in Southern California and a bit below average for mid-August and late August in Northern California. So temperature-wise, this is not going to be a hot period across most of California. In fact, it may even be a fairly cool period, especially relative to recent extreme heat. But there are already signs on the horizon of another major heat event across the interior Southwest by the end of August and early September. This one may not be centered on California, so we may not see as much widespread record-breaking type heat, but it will be a whole lot hotter than it is now, and parts of Arizona and New Mexico may break August records once again. So parts of the West may be headed back for record heat, and California, especially Southern California, may be on the periphery of this as we head towards late August. So I'll touch on all of this a little bit more in a moment. Wanted to mention briefly the Park Fire, the one that has garnered the most attention this year in California thus far, nationally and internationally even, and for understandable reasons. It has burned around 430,000 acres so far, and I will say, given recent lack of activity and aggressive containment on the northeastern flank, which had been very stubborn, burning in very heavy forested region with very heavy fuel loading, has really calmed down, and there's not much activity visible from satellite imagery, not many hotspots, not much smoke, and I think there's a reasonable chance that the fire has largely reached its final footprint. There might be some interior islands that burn in the coming days. There may be even some intentional backburns to tie in existing lines and strengthen control lines in different spots. So we may add a few thousand more acres before all is said and done, but relative to the amount that's burned so far, I don't expect there to be a great deal of further growth, if any, so long as nothing unexpected happens. So in all likelihood, the final footprint of this fire is going to be right around where it is now, 430,000 acres, which will put it squarely into fourth place as California's largest modern wildfire. As many ecologists and fire scientists will point out, the size of wildfires is not a great indicator of their impacts, and this is a really classic example of this, where there has been both substantial benefit even from this fire in some ecosystems, particularly the grasslands, which comprise a large swath of the western half of this fire, but also quite a lot of harm, both to ecosystems, especially some of the forested ecosystems that this fire ran through at a very high intensity as it was burning upslope under extreme fire weather conditions in recent weeks. So these would be Mill Creek and some of the other drainages that were heavily forested and that this fire burned through at an incredibly high intensity. And also, of course, the people who lost their homes. And there were around 600 structures destroyed or damaged, I believe, in this fire, which is quite a substantial number. So somehow that actually hasn't made the news as much as I might have expected. I guess it's relative to recent decade or so of wildfires in California where there were numerous fires that consumed hundreds of structures. And so this just gets added on to that list, I suppose, in a certain sense, but of course very consequential for the relatively small, and in many cases rural communities that lost dozens or even hundreds of homes in this fire. So this was not an inconsequential event for them, those folks, nor was it an inconsequential event for those forested ecosystems that will probably in our lifetime not look the same because of the combination of the high severity fire and the climate changes that we know are making it more difficult for forests to reestablish themselves in many parts of the West following intense fires. So another example of a fire with mixed ecological effects. Some benefits, some harm, depending on where you were. Definitely harm to humans in the context of structures destroyed and also disruption. There were some folks who were evacuated for multiple weeks on end during this fire. But just another example of how the majority of the damaging parts of this fire occurred in a far less than half of the acreage burned. It might well be the case that more than half the acreage burned was ecologically beneficial, but the other 30 or 40% of the area that burned was harmful both to humans and probably the ecosystems that it burned through in many cases. So it's never quite a simple story. The 430,000 acres doesn't tell the tale. Fortunately, there were no deaths in this fire. There were some injuries, mainly to firefighters, but that I think is unfortunately something that is a genuine occupational hazard on a fire this large and this complex. When there's thousands of firefighters working on an event for weeks on end, there are often injuries. So that's the park fire. I think that story, at least in terms of the active fire, is largely wrapping up. There is a very slight chance that there could be a flare-up during this weekend's potential red flag conditions, windy and dry, that could pose some problems, but at this point I think that fire is largely wrapped up. Now the main impacts will be in the post-fire environment in terms of recovery and also the post-fire ecological and hydrological impacts, which will linger for years, as mentioned. But there are other fires in northwestern California. There's a couple of significant fires burning in heavy timber right now, and as well as there are still some active fires burning in the southern Sierra Nevada in fairly remote regions. Not causing huge problems at the moment, but they may become more consequential with this weekend's incoming windy and dry conditions. Even though it will be cool, there will be a large increase in the fire weather risk this weekend across parts of California. I'll talk about that more in a moment. So that's the fire situation. Right now, we are essentially in a lull, and we probably will be. I guess I shouldn't jinx it, because there will be a couple days this weekend in parts of interior northern and central California, particularly Sierra Nevada and the northern mountains, where there will be very high fire risk. And although there aren't a large number of large fires to be pushed along by this severe fire weather this weekend, any new ignitions could really take off, and that is a real concern with the upcoming weather this weekend, although next week looks once again fairly favorable. Cool, less windy, less dry. So if we can get through this weekend without new ignitions in the Sierra, it might be a continuation of the calm period. But as I mentioned, with the heat returning, anomalous heat, potentially even highly anomalous heat across much of the West, by late August and early September, I would expect to see another resurgence in wildfire activity then across a broad swath of the West, including California. And as I'll talk about in a moment, the long-term outlook for autumn continues to suggest that the predictable portion of the autumn fire season, which is to say how hot will it be, and to a lesser extent, do we have any predictability about whether it will be dry or there'll be a delay in the onset of the rainy season, that continues to point pretty strongly towards an unusually active autumn. And that raises the concern of wind-driven autumn fires during what is canonically the coastal California's heat wave season and offshore Santa Ana Diablo wind season. That season in particular this year, the wind-driven autumn fires in California could be especially consequential, and for that reason, I don't think we've seen the peak of fire season most likely yet in California, at least not in the more highly populated coast ranges, Bay Area, and in coastal Southern California. That will probably come in September and October, and it could be a very active period if current indications are correct. Could we get lucky? Could there be a late season tropical storm remnant moisture event like we saw last year with Hillary that soaked Southern California and pretty much decapitated fire season, if you will? Or a couple of years earlier, we saw some early rains in Northern California early in the autumn that really cut off fire season early. We don't have the ability to predict either of those at seasonal scale. I will say that relative to average, the likelihood of seeing either a tropical remnant event or an early onset to the rainy season is slightly lower than even it would usually be, and the odds would already be fairly low on average, but not negligible. This year, I think they're even lower than that. So on the rainfall side, I think it's more likely than not that we won't see a season-ending rain event in most of California this month or in September, or perhaps not even in October for much of the state. So a little bit later onset than usual, but the much stronger indication is that the next 2 or 3 months will be much warmer than average, and that anomalous heat will extend increasingly close to the coast as the offshore flow season, if you will, which tends to peak in autumn, really allows that heat to pervade the coastal zone as well as inland areas. So that's sort of what I'm thinking in terms of the seasonal outlook, is that we may see a little bit of a break now, punctuated by occasional days of elevated fire weather like this weekend, but there will likely be another increase, a double peakedness, if you will, of fire season, that second peak not coming perhaps until later in September or even October in some spots. So fire season is not over yet, and a lot of times the most dangerous and destructive fires from a wild and urban interface perspective, in other words, where people live, where those homes are intermingled with the vegetation in California's suburban and semi-urban areas, that often happens later in the season, in September and October, when vegetation reaches its peak seasonal dryness, coinciding with the time of year when those strong, dry, and often warm or hot offshore winds are most common. This year, the risk being amplified, of course, by the record-breaking antecedent heat, as well as the relatively damp conditions last winter and the winter before, which led to extra growth of grass and brush, and the record heat in July, which kiln-dried all of that extra vegetation, particularly in the places that are most susceptible to wind-driven brush fires in autumn. So, sort of starting out with the longest time scale first, that's your autumn preview in terms of fire season. Then I'm going to telescope backward to get us to the present. In fact, I might telescope all the way backward to the present right now and talk about this weekend first, because there's some very interesting weather going on. And I'm actually going to switch over, so you won't see me talking for the moment, but you're actually going to see my screen. So bear with me as I shift here. You're going to see the infinite mirror, because I don't have a better way of doing this. If I'm going to use my screen sharing tool, which I do want to use. So the first thing I'd like to show is, let's see here. Okay. Let me just pull up the right variables here. This is what I want to show. So this is the European model, 500 millibar geopotential height anomaly map. I'm going to scroll down so it's more centered on the screen. Again, this is one of my favorite weather websites, tropicaltidbits.com, operated by Dr. Levi Cohen. So I'm going to advance forward in time, this is the present, this is the analysis for earlier today. This is going into this evening and into the weekend. What we see is a remarkably deep low pressure system form off the coast of Oregon and Northern California. This is something on the order of a 2 sigma standard deviation geopotential height anomaly in the negative direction. So this is about as anomalous on the negative side of things as our record-breaking heat dome was in July. Now, it won't be nearly as persistent, and because of global warming, it won't bring as cool of temperatures as the middle tropospheric anomalies might suggest. But this is still a notable low-pressure system for mid-August. This is not something we would typically see this early in the season, arguably still right smack in the middle of summer, or at least in the second half of summer. This is maybe more of an autumn-like system, and we're not in autumn yet. And the reason why this will be consequential is seeing an autumn-like system in summer means that there's summer-like heat and humidity on the fringes of the system, like there would not be in autumn. So we have a kind of a dynamic combination of several different factors here. So going forward into the weekend, this is what this setup will look like early Saturday evening along the west coast. Again, a deep low right near the Oregon-California border, which then slowly moves northward and inland, or actually, it sort of stalls off the coast of Oregon and Washington, lifts northward away from California as you go into Sunday, and then weakens sort of in place. So it doesn't really, I guess in this case, it's not really propagating away. It's mostly just weakening in situ Monday into Tuesday before moving inland, and then being replaced by potentially another low-pressure system later next week. So this is another reason why next week's fire weather will be mixed. Definitely see cooler conditions, but could see low humidity and windy conditions associated with this strong pressure gradient associated with these low pressure systems. Actually, I hadn't looked at this yet. This is an interesting solution for Northern California this is a week out, so there's some uncertainty. I'll talk about that in a moment. Okay. So what does this look like in terms on the precipitation side of things? So again, this is starting right now. There are already some thunderstorms and showers off the coast of Oregon. This is heading into Saturday, so as we get into Saturday morning, there may actually be, believe it or not, some rainfall along the coast, the northwestern of northwestern California on Saturday. So from late morning into early evening. This is, again, the European model showing some substantial showers along the Del Norte County coast, so up by Eureka, Arcata, and maybe even as far south as Mendocino County. So even Ukiah could see a brief period of some lighter showers later on the day on Saturday, as well as sort of the northern mountains, so the Mount Shasta, Lake Shasta region, chance of some brief showers before the whole system lifts northward. So this will be a brief window, but at least along the north coast, this could be a decent episode of some decent soaking rain. I doubt it will be a soaking rain in Mendocino or inland, but it well could be along the north coast, and there could be measurable showers elsewhere as well. Again, all of this will be well north of the San Francisco Bay Area, so this will not get anywhere near close to San Francisco or Sacramento. But this may affect maybe perhaps as far south as Redding, a brief shower potential in the northern Sacramento Valley, and maybe the Ukiah area is looking like a plausible place for a shower or two tomorrow. And you can see this blob of precipitation lifts northward across Oregon and Washington. So that would be notable enough in its own right, but due to the relative rarity of midsummer precipitation. But the more interesting thing is that as this lifts northward, it's actually going to be quite an unstable air mass and associated with a lot of thunderstorm activity all the way from far northern California, but especially up into Oregon and Washington. I'm going to talk about that in a moment. But I just wanted to, interestingly, the European model is suggesting that something similar could happen about a week from now and potentially extend a bit farther south with some thunderstorm potential. So I'm taking a look at that in real time. But if we look at the ensemble, though, this is all the different numbers of the same model averaged over the same period, which gives you a better sense of the range of plausible outcomes. Let's take a look at what this looks like. And again, through a Monday, not a tremendous amount of precipitation. If we look at the Northern California coast, but also any number greater than 0 is notable this time of year, locally up to a few tenths of an inch. So I wouldn't be surprised to see 1 or 2 gauges up along the north coast see somewhere from 0.3 to 0.5 inches of rain over the weekend. Not bad for August. Again, the ensemble average, once you get down to Mendocino County, is more likely on the order of hundredths. So maybe a 0.01, maybe a 0.05, maybe if you're really lucky, a 0.1 in the northern part of the county. Same thing goes for the northern Sacramento Valley, most likely just 0 to a few hundredths up by Shasta, but a few tenths possible up along the north coast by Monday. In Oregon, especially west of the Cascades, so some of the Willamette Valley westward, well, actually the Cascades westward to the coast, really, a pretty good chance of measurable precipitation that will likely be a wetting rain. Not a heavy rain necessarily. The area average for western Oregon looking more like a few tenths of an inch. So a soaking rain, but not a deluge by any means. Probably wetter up on the western Washington Olympic Peninsula. Probably sees the most out of this. Unfortunately, the most voluminous downpours will probably be offshore over the ocean, where no one necessarily benefits from them. But this will be a meaningful amount of rain up in Washington, Oregon, and locally along the north coast in California as well. Again, this is what the ensemble is showing for that second system about a week from now, as I mentioned. Very slight chance of some showers a bit further south, but not nearly as interesting as the ensemble average. Looking forward as we get towards late August, just wanted to show sort of that evolution. So you see this low pressure system this weekend, it lifts north, it fades away. There's a secondary one, and then as we get towards late August, let me actually bring up the normalized map. That's what I intended to show here. So there's an initial low pressure system, just as I was talking about, and then a bit of a secondary one about a week from now. That's this one here. You can see that again. But after that, a very strong subtropical ridge builds in near the Four Corners, and then the southwestern flank of the ridge across New Mexico, Arizona, and central and southern California really takes off as we get into the last week in August. Pretty high confidence this is going to be a pretty hot period. Once again, an anomalously hot August. And if you look, this is a very broad ridge. Really, all of the western U.S. is under some degree of anomalous ridging, some more to a greater extent than others. And in terms of temperatures, what we're likely to see over this window, again, northern and central California starting off this coming week cooler than average in most spots. Still some pockets of warmer than average in southern California. But as you get towards the end of the month, though, things remain cool for about the next 10 days or so before warming up quite a bit. And as we get towards late August, potentially, except along the immediate coast, seeing a broad swath of much above average temperatures across most of the west. So that's this expectation of increased heat as we get towards late August and early September. So I'm just going to take a quick break here. Make sure everything's going well on the live studio side. It looks like it, so I'm going to go back to screen sharing over here. Okay, so, and I don't as often talk about the Pacific Northwest, but given what's going on, I think it's kind of interesting to do so. Again, here's a zoomed-in version of the European model precipitation outlook showing, this is from the higher resolution deterministic run, showing once again that there could be some pockets of Northern California that see a few tenths of an inch of rain this weekend. Not bad. Again, showing a dividing line somewhere around the northern half of Mendocino County with just a chance of some sprinkles south of that. Again, maybe a tenth or two near Mount Shasta. So good news in terms of some rain up here. Better news, western Washington and Oregon, where more widespread rain, locally as much as half an inch or so, maybe even locally a little bit more, could fall with this system. But the more interesting piece is the potential for significant lightning during this period. So I'm pulling up the severe weather tab here, which I don't always do here. Looking at this is called the most unstable cape. So I'm just going to toggle through here showing the layer of the atmosphere that is the most unstable of all possible such layers. This again is starting Saturday morning. You can start to see some instability, a few hundred joules per kilogram popping up across portions of southwest Oregon and off the coast of far northern California. As we get into late morning and afternoon, this is some pretty robust instability. So off the coast of northern California, this includes off the coast of Del Norte and Mendocino counties, 700, 800 joules of CAPE is nothing to sneeze at by California standards. Also, even some weak positives, the low 100 joules all the way down into northwestern Sonoma County, Lake County, going up north from there, higher in Oregon again. And as we step this forward a few more hours into the afternoon, we see much higher CAPE up in Washington, Oregon, very unstable air by regional standards, but also a pretty widespread swath of at least some modest instability, again extending all the way from northern Sonoma, Mendocino, Lake counties into the northern Sacramento Valley, maybe even a few hundred joules of CAPE up by Redding, higher than that by Eureka. We go into Saturday night. There's a little bit of residual instability over far northern California, but this is mostly on the way out. But look at what happens up in Washington and Oregon. 1,500, nearly 2,000 joules of CAPE in the overnight hours on Saturday. These are very high values, 1,500 down up Oregon, Washington. These are uncommon levels of atmospheric instability. And because I can pull this up here, one other variable I wanted to show is, I believe it's here. Yes, it is. So the lightning. This is an interesting product from the European model showing lightning potential flash density. So it literally is per square kilometer, how many flashes in a 24-hour period ending in a 6-hour window. And so we start with right now. There's not a lot going on along the west coast. A few thunderstorms across the usual suspects inland areas. Maybe an isolated storm in southern Oregon later today, but not much. Here we go into Saturday morning. Nothing to talk about here. But we get into Saturday afternoon. We see some pretty high odds of lightning starting to show up off the coast of northern California. And then this is right around 4 or 5 p.m. tomorrow evening, Saturday. Whoa. Look at that. That's a pretty significant level of lightning activity across a good swath of northern California, all of western Washington, all of western Oregon in the early evening, and this will spread northward into western Washington as they go into the next time step. That's a whole lot of lightning. Seattle, Everett, Portland, all the big northwestern cities, major lightning potential in the overnight hours, Saturday night. As I mentioned, it's moved north of California. I'm going to back up a little bit because in the peak window of lightning for California, there is at least a little bit of slight lightning risk extending as far south as even Lake County and Colusa County. So although it's not likely, the odds of some isolated lightning strikes are not zero as far south even as maybe the very northernmost part of Sonoma County into the central Sacramento Valley. And points north and east. Now, as I mentioned, these are unlikely to be dry storms for the most part. They will be mostly wet storms, especially as you get up into the coastal parts of northwestern California and Oregon and Washington. But the initial storms could start out somewhat dry, and also any lightning that occurs in the southern or eastern fringe of the zone could also be essentially dry lightning. And this is something to watch out for, because although this isn't going to be a widespread dry lightning outbreak per se, it will be mainly quite a wet lightning outbreak up in Washington and Oregon and far northwestern California. There could be some dry lightning strikes on the fringes of this, and I have seen a few similar systems in the past that develop a very narrow trailing band of isolated lightning strikes on the far southern edge of the cold front, such as it is in this environment. So I would not be extremely surprised to see a narrow band of isolated thunderstorms extending even farther south than this, maybe even into parts of the North Bay. I'd call that maybe a 10 or 20% chance, or the Sacramento Valley north of Sacramento. That would pose a higher risk from a fire weather perspective because there could be some lightning ignitions there, although not widespread and not likely. It is possible, and they'd be followed up by strong gusty winds, which would of course be a not so great combination. And just to remind folks, that the total amount of precipitation it's likely to be close to 0 right along the fringe there. So most spots will see wetting rain, as I mentioned, up in the Pacific Northwest. So not much fire risk up where there's going to be the most lightning up by Seattle. Some lightning risk in parts of Oregon because, as I mentioned, there will be rain associated with these storms, but it won't be a tremendous amount. We're talking about a couple of tenths of an inch. That's enough to prevent fires from initially taking off and reducing the risk of lightning ignitions, but not bringing it to 0. So there could be a number of holdover fires in sort of northwestern California and central Oregon zone, potentially, because although there will be some rain, it won't be enough to completely extinguish smoldering trees, for example, in densely forested pockets. So we might see holdover lightning fires pop up later next week. Stay tuned for that one. So an interesting weather event in Northern California, not just because of the lightning potential and the rain, especially up in the Pacific Northwest, but I also want to talk about the potential for some surprisingly active thunderstorms themselves. So looking at the Pacific Northwest, this is the Storms Prediction Center, the NOAA Center tasked with severe thunderstorm prediction, among a few other things. And I wanted to share this map for Saturday. What this is showing up in the Pacific Northwest is a substantial potential for severe thunderstorms, including some parts of the Willamette Valley. So this does technically include Portland and all of the towns and cities along the I-5 corridor between Medford and Vancouver, Washington, but especially the more interior portions of the Cascades. So this is mainly due to the potential for strong winds and strong winds and large hail. So there could actually be a severe thunderstorm outbreak in Oregon tomorrow. The conditions are favorable. Negatively tilted trough in August with a pretty deep low, some good instability is not a typical combination. So this is a fairly rare setup for the Pacific Northwest. A major thunderstorm outbreak, including some severe storms, are possible. If you notice, there's a slight chance of even a few severe storms extending into far northwestern California. It probably won't be a big deal. Not a lot of people live in this particular dark blue swath, but still something to note. These could be pretty robust storms. But the other piece I wanted to mention in this context is the fire weather concern. And this would be, well, let's see if we can get the best map here. I'll do the zoom out version first. This is the Saturday fire weather risk. The brown region here, this is where there is some concern over dry thunderstorms. This is the primary risk of dry storms. I personally think there is some risk. I would draw it further south as well, though it's a little more conditional. But the clearer problem, I think, will be, and I'll zoom into two different regions, up in Oregon, very windy and dry conditions. It's not going to rain here, but you are going to get a lot of wind and low humidity associated with the storm system. So there's some overlap of the windy and dry region with the dry lightning zone up in Oregon. That could be a problem. But also some of the dry and windy conditions where it won't rain extends into northern California and Nevada and the Great Basin. And so if we zoom into Nevada, this is maybe a better view from a California perspective. Far northeastern California with elevated fire weather, but the southern Sierra and the eastern slopes of the Sierra in particular up with critical fire weather, along with large portions of the Great Basin with dry and windy conditions. There could potentially be a significant wildfire event somewhere in the Great Basin tomorrow, because there's been a lot of growth of vegetation this year with all that extra grass filling in the gaps in the desert due to all the extra rain the past 2 years. This is a pretty critical fire weather event, and there's not going to be rain in this region this weekend. So the central and southern Sierra, especially the eastern slopes, eastward into the Great Basin, potentially a major fire weather event tomorrow. I wouldn't be too surprised to see some fire red flag warnings go up for portions of the Sierra Crest, for much of western Nevada, eastern Oregon, and maybe also pockets of northern California outside of places, maybe along and east of I-5, up in far northern California, that might get wind, a slight risk of dry lightning, and probably not much rain. So, okay, I think that's mostly what I wanted to show on the maps. I'll go back to the period where to the version of this where I can see everybody. You'll see me come back again momentarily. All right, so I'm going to answer some questions. Folks may well have some, so let me just take a sip of water and I'll get into it. There's a question. One of the first questions was actually about the potential that a trough about a week from now off the California coast could draw some moisture northward from the tropics. That's, I think, what we're seeing in that individual European model run that I mentioned. It's not especially likely. It's also not impossible, frankly, right now. Maybe we'll see it. If that happens, this time of year, it's sort of a double-edged sword. One possibility is it brings, fire season mitigating rainfall to a wider region. The other possibility is it brings a dry lightning event, because that is the canonical classic pattern for one or both of those things. And it's not always clear in advance what it would look like. So right now, I'd call it a less than 20% chance, maybe between a 10 and 20% chance. So definitely not likely, but also not impossible. I'll talk about next week if that's going to occur, and at that point it might be a little clearer whether it would be associated with any precipitation or more dry lightning risk. Focus on this weekend's event for now. There's a question about why record warm ocean temperatures haven't yielded a record hurricane season compared to the temperatures yet. I'm assuming this refers mainly to the Atlantic basin, because the large-scale atmospheric conditions favored a very inactive year this year in the eastern Pacific, as it has been, but a hyperactive year in the Atlantic. And one thing I wanted to point out is that hurricane season is very strongly backweighted towards late August and September. So we are actually well above average hurricane activity in the Atlantic basin to date. In fact, we're ahead of almost every single historical year in terms of the accumulated tropical cyclone energy in the Atlantic basin, except for one other year in the observed record. So we're actually nearly record-breaking levels of accumulated hurricane intensity from the storms that have occurred, and the peak of the season is rapidly approaching. So I actually don't think it's correct to say that hurricane season has been mild. We've seen one of the most energetic hurricane seasons so far on record if we use a metric that integrates the duration and intensity of the storms that have occurred in the Atlantic basin, while also acknowledging that in almost every year the season rapidly accelerates from here on out anyway, reaching a peak not until September. So I think we're still likely to see a very high peak, because to date we're nearly at the top end of that scale, except for one or two other years at this point already. There's also a comment about the Texas heat wave. Yes, there will be an upcoming, it's an ongoing and long duration, another severe to extreme heat wave in Texas. In some parts of Texas, of course, it's a very humid heat, which makes it even more dangerous. This is partly associated with the large-scale weather pattern. The troughiness along the west coast, which, as I mentioned, is quite unusual for August, means that there is therefore unusual ridginess somewhere else, and in this case, it's about there. This is the ridge that will eventually shift westward and strengthen even more near the Four Corners about 10 days from now, bringing a potentially record-breaking heat wave further west into New Mexico, parts of Arizona, and a potentially significant heat wave even into parts of central and southern California as we get toward the end of the month. So it's all part of the same pattern. Everything is connected and all that. But it's just yet another example of extreme heat, and in that case it's quite humid heat, and therefore especially dangerous heat from a human health perspective. Several folks have mentioned that today and this week is the anniversary of the August 2020 extreme dry lightning storm in the San Francisco Bay Area that resulted in numerous and in many cases catastrophic wildfires. Just to clarify, there's nothing on the horizon like that right now, although there are echoes of it in the sense of the potential for a slightly unusual out-of-season thunderstorm event, although these look like mainly wetter storms up in the Pacific Northwest and far northwestern California this weekend, and the slight chance of some other kind of event with the tropical remnant event later this week, as had been mentioned which could either bring a little bit of precipitation or could bring risk of dry lightning, about 20% chance of that. It is interesting to reflect. It feels like it's been about 20 years, but in fact it has only been 4 years since August of 2020. And a lot has changed in California in terms of wildfire response and preparedness. Much of it for the better, I would actually argue. So I do think in some ways we're in better shape. But the climate continues to warm. We just experienced our singularly hottest month on record. July, by the way, this past July was hotter than either August or September of 2020. Even though the level of extreme heat along the coast was higher in those years, July of this year was already hotter than that. So what we don't have is the widespread dry lightning. What we don't have is the legacy of a historically severe multi-year drought like we did then. So that's not in place right now. So as I mentioned, we're not in the same place. I would not expect necessarily to see an August 2020 level fire siege, even if we had an August 2020 level lightning event currently. And that level of dry lightning was phenomenally intense in the Bay Area. It is possible that most people won't live to see another dry lightning event as dramatic and extreme as that one. Well, almost certainly, all of us will live to see new dry lightning events in different parts of California. There's some form of them almost every year, and some years the recurrence interval for very significant dry lightning busts, as they're called, is about once a decade or so in California. So they're unusual, but they're not super rare. So it's an interesting thing to reflect on as we have another year with another summer that has had some record-breaking heat, and where there are some hints of a significant autumn fire season to come. Could be made a lot worse if we did get a dry lightning event. Could be made a lot better if we get an early season precipitation event that sort of heads things off at the pass. And at this point, no direct indication of either of those things at the moment. I think I answered Marty's second question about fire intensity. Well, actually, maybe I didn't answer it directly. So the question is, there's a lot of media coverage of acres burned, but they all treat all the acres burned as the same. Have you seen anyone doing research on fire intensity and impacts? So I talked about why this matters and why acreage burned does not tell us everything we need to know about the impacts of a given fire. There is a lot of research that people are trying to do on this. The problem is it's actually quite difficult to do it at scale, because the way it was done historically is people would manually map out from the ground. Ecologists would walk the burn scar, if you will, and look at the fire effects. That doesn't work if you're trying to do global assessments of changing fire intensity. Fires that sometimes are 100 miles on a side and occur in very remote parts of the Arctic, or the remote forests of the western U.S. or Canada or something like that. So what you need is to be able to do this systematically, and the way to do that is through remote sensing, mainly meaning through satellite measurements. And we only have good satellite measurements of wildfire intensity going back about 20 to 25 years, depending on the data set. So 5 or 10 years ago, when we only had 10 to 15 years of data, you really couldn't say anything about trends at all. 10 years, 15 years, it's just not long enough. 20, 25 years that we now have is just enough if there's a very strong trend to be able to discern it. The signal-to-noise ratio is still low, so the signal's got to be really strong if we're going to be discerning anything. But it's just a long enough period that scientists have only begun to look, and lo and behold, they find the signal because the signal is just that strong. That even though we only have 20 to 25 years of data, there has been such a substantial increase in the intensity of wildfire, especially in the mid-latitudes. So really everywhere but the global tropics have seen this intensity increase, that we can now observationally confirm that the intensity of wildfires is actually increasing. Not just the acres burned, which is, as we mentioned, is an imperfect metric. We already knew that was increasing rapidly outside the tropics. But the more important question was the intensity increasing? And the answer is pretty clearly yes. We're seeing essentially a doubling of extreme fires over just a 20-year period or so outside of the tropics. And that is a pretty remarkable number. It's a short period of observation, which usually means you can't say anything unless the trend is very strong, which it appears to be. So the short answer is yes, we're limited by data, but the theory certainly predicts that fires should have increased in intensity given climate change and the other landscape level factors that we talk about in many of these sessions, including changes in land management and fire suppression historically. But what we can confirm is that in most regions globally outside the tropics, which is to say most regions that we think of when we think about forest fires or brush fires in temperate mid-latitude zones, like California and the western US, for example, that the intensity is increasing quite a bit at the same time that the acreage is increasing. So it's not that we're seeing more fire, but a greater fraction of it is burning at low intensity, which might actually be a good thing. But what we're actually seeing is larger fires that are in turn burning much larger areas at higher intensity, and that is probably not a good thing. So we have been able to confirm that just this year, but that's a fairly new thing to be observationally confirmed from a scientifically robust perspective rather than just inferred from disparate lines of indirect evidence. Now there's some direct evidence pointing in that way. Let's see. One comment that the grass is still green and growing at the 7,000 foot level in BV, I'm guessing Bear Valley. Can you point us to a good source for up-to-date vegetation dryness data? Yeah, that's what I'm hearing, is that up above 6,000 or 7,000 feet or so, we still have the legacy of 2 consecutive near to above average winters and mild springs. Fire risk is not dramatically higher than average. In fact, it might actually be a little bit lower than average at the very highest elevations still. It's not to say that there's snow still on the ground, but it's saying that the residual moisture from the snow that melted earlier this season is still having a beneficial effect up there. So the transition point appears to be around 5,000 or 6,000 feet, where the vegetation is much drier than average below that level and not much drier than average, or even maybe near to above average moisture levels above that. So the context is important. The other challenge is that as we go into September and October, fire season tends to shift downslope to the lower elevation regions, as offshore winds tend to affect the downslope, western slopes, and valley regions more often than the mountain tops. And as temperatures cool down quite a bit, especially at night, once you get into late August and September at the high elevations in the mountains. So this really becomes more of a coast range and coastal plain and valleys in between, as well as the western slope of the Sierra Nevada type fire season as we go into autumn. And that is precisely where the vegetation is going to be the driest in that window. The best option that I would suggest would be the Northern California Geographic Area Coordination Center website. So if you Google NorCal GAC, G-A-C-C, you'll get the website, and there's some fairly convoluted tools to look at the current state of vegetation at moisture and fuel moisture there. There's a quick question about whether ocean temperature means the surface temperature of the ocean or the whole volume of the ocean. Presumably it's the surface temperature, but the whole volume is longer lasting. Yeah, you're exactly right. When we hear about ocean temperatures, generally we're talking about sea surface temperatures, which is literally the temperature of the uppermost skin of the ocean, if you will. So if you stuck your finger in the ocean and your finger had a thermometer probe taped onto it, that is the temperature that you would be measuring. Those are the sea surface temperature. Those are the values we're usually mentioning. Of course, the deeper ocean is warming too, but it takes much longer, as you'd expect, because the thermal inertia of the deep ocean is enormous. So the fastest oceanic warming is occurring near the surface in most cases, but the ocean is also warming at depth. It just takes a whole lot longer. Yes, I suspect if you're in Eureka, you will not have to water your lawn tomorrow, or perhaps not even for a good 5 to 7 days, depending on how willing you are to let the rain do its thing this weekend. Let's see. So I was showing a map earlier of CAPE, of Convective Available Potential Energy, CAPE being the acronym. Really what it is if you just ignore the first word for a moment, available potential energy. It's really just a measure of the potential strength of an atmospheric updraft, say in a cumulus or cumulonimbus cloud, so inside a thunderstorm, that driven purely by the buoyancy of the atmosphere itself. So you can imagine if you take a rubber ducky in a bathtub and submerge it, or a sealed, say an empty bottle with a cap on, and push it underwater, there's going to be some resistance, and that resistance to pushing it further and further underwater is going to grow the deeper you try to push underwater, because the air in that closed chamber, in that sealed chamber, is causing that object to have very high positive buoyancy. So obviously the air inside the sealed chamber is much less dense than the water that it's displacing, and so essentially Archimedes' principle, it really wants, essentially you're giving that object potential stored energy, right? Because if you put that rubber ducky under 20 feet of water, the bottom of a swimming pool or something, and let it go, what's going to happen is it's going to rocket upward toward the surface, right? Because that's the potential. So you've given it potential energy by virtue of struggling to bring it to the bottom, and then you're releasing that potential energy when it then rises through the column. Same idea with convective available potential energy. It's saying how much is the ambient state of the atmosphere giving that parcel in the lower atmosphere propensity to rise upward in similar fashion. So usually in California, the number is 0. There is no convective available potential energy because the atmosphere is absolutely stable. There's a little perturbation that gives the atmosphere a kick and nothing happens. In fact, sometimes it's so stable that even if something pushes the air up, say a coastal sea breeze pushes the air up above the coastal mountains. You see this with the fog in San Francisco coming over the hill, for example. If the atmosphere is very unstable, that initial kick with that moist air near the surface might continue to grow up and up and up and up well above the height of the mountains and form showers and thunderstorms, as it would in a tropical location with mountains. You see this all the time, say on a tropical island with mountains. Those initial little clouds that develop for the sea breeze will grow and grow and grow on their own and become 10 times taller than the mountains that initiated their growth. But in California, that fog is just sticking almost like glue to the top of the mountain and then falling down immediately because the atmosphere is subsident at pushing that air down and really not allowing those clouds to grow. But in this kind of condition, this unstable atmospheric environment, you have positive buoyancy, and the larger the cape, the larger the aggregate positive buoyancy, the larger the potential energy of the atmosphere. If it gets a little initial subtle kick by topography or wind convergence or frontal lifting or something, really anything, it can continue to spontaneously rise, cool, condense, develop into convective clouds and thunderstorms, and that is what we expect to see this weekend across the Pacific Northwest, as well as a few of the northernmost counties in Northern California too. Several folks mentioning there already are red flag warnings up for most of southern Oregon and parts of Nevada. I haven't looked at that in the last couple hours, so that's probably new, but I believe it. Probably for a combination of locally dry lightning, but more widespread strong winds and low humidity. But do watch out for the potential. I personally think there's about a 10 or 20% chance that a very narrow line of isolated thunderstorms could extend about 100 miles southward of where the models are currently suggesting it. So that does mean that Mendocino County, Lake County, parts of the Sacramento Valley could see some lightning. Low odds, but high consequence if it happens. Maybe even Sonoma County if it extends particularly far south. So again, that might not be in the official forecast, possibly because it's less than the 10% threshold for mentioning it in the official forecast, but I wouldn't totally rule it out. Alex asked, when all is said and done, how likely is it that the fire season in 2024 will be as severe or more severe than 2020 or 2021? I think there's almost no chance that it's as bad as 2020. 2021 was a much less severe season. There was still the Dixie Fire and some other major events, but it was not nearly as absurd as 2020. So there's at least a theoretical possibility we end up closer to 2021, but I think it's almost impossible at this point. I would never say never. A lot of folks, including myself, might have said that the 2020 fire season was nearly impossible until it happened, so I don't want to jinx anything, but just given what's happened to date and what probably will not happen in the next 2 weeks, I think that's unlikely. But 2021 could potentially be a closer analog, but no two fire seasons are the same, and there could be, you can get lucky or unlucky. You can have a very large fire that does very little harm and a very small fire that does tremendous harm, depending on the context. So it depends how we measure it. Are we likely to get to 4+ million acres this year in California? Probably not. Almost certainly not. Will we exceed 1 million acres? I think there's a good chance we will. So that would put us at well less than 2020, but still well above the long-term average type season. But the harm brought about by that, 1 million acres is really anyone's guess. If there's a big fire out there in the wilderness, less harm. If it's a mixed fire, like the Park Fire was mostly in the wilderness, but it did still manage to burn hundreds of structures, that could be a big problem. But even a 5 or 10,000 acre fire in the suburbs of LA or San Diego or the East Bay Hills or something like that could burn thousands of structures during a Santa Ana wind event, hypothetically. So it's almost impossible to make that prediction, but I do think the likelihood of unwanted destructive fires does go up in seasons like this one, where there is likely to be much warmer than average conditions and drier than average conditions in the parts of California that are most susceptible to the risk of wild and urban interface losses during wind-driven fire events. And that's consistent, by the way, with the seasonal outlook from the official federal predictive services for wildfire, which do suggest above average large fire activity likely developing coastal, central, and southern California later this season, beginning about in September, and perhaps continuing into even November or December in some spots in Southern California, or until the rains arrive, whichever comes first. All right, I'm just skimming the last few questions, see if there's anything else I'm going to take, but we've gone past the hour, so let's just see here. Oh yes, and there's one other thing I didn't mention about the long term. There could be some westward surges of late monsoonal moisture as you get into late August during that strengthening ridge event over Arizona and New Mexico. It's kind of like a peak monsoon level Four Corners ridge, so there could be some mountain and desert and locally west of that point monsoonal moisture and thunderstorm activity later in August. Too early to understand the details, but that could pop up. And I think, although there are some other good questions, I think for the sake of my voice, I'm going to need to call it a day. Thanks everybody for joining. You can always help out by liking these videos, and in particular by subscribing to the channel. A short-term goal is to get to 10,000 subscribers. I think we're at about 8,500 right now. So there's a ways to go, but I think that's a manageable short-term goal. Sharing these videos, it's gotten harder to share on social media. Actually, X and Twitter is unfortunately now actively suppressing external links. So when I share the Weather West blog or the YouTube channel, they get very little viewership there. I do, of course, share across a bunch of different channels now. In addition to Twitter or X, I share on Blue Sky, Threads, as well as Mastodon. And here on YouTube, the YouTube live sessions are, of course, kind of unique. I don't do anything like this anywhere else. But it is helpful if other folks share this across those channels because people are more inclined to see it if it's coming from multiple sources rather than just from me. So thank you for that. And glad we made it through the full hour without any squirrel-related or connectivity interruptions or otherwise. So, knock on wood, hopefully that continues. All right, thanks everybody. Have a good weekend. And if you are up in the Pacific Northwest or far northern California, enjoy the thunderstorms tomorrow. Hopefully there aren't too many fire ignitions in the red flag warning zones. And I'll keep an eye on things, satellite and radar tomorrow, and if something really crazy starts happening, I might do a quick pop-up session. We shall see, but hopefully there won't be an occasion to, and it's just some good old August showers and embedded thunderstorms rather than any widespread dry lightning or lightning developing in unexpected places. And with that, I think I'll see you next week.